So you've got us as a captive audience. So yeah, Robbie, please take the floor.
Yeah, thank you. Hey, thank you so much for having me at the meetup. I'm super excited to be talking at Cloud Native New York. So let me share my screen. Move a few Zoom things around. Thanks. I actually took that photograph with an iPhone 7.
That's a good one.
Wow.
Yeah, it was like, I had to go to Australia a couple times. And like, you just super jet. Like, Australia is really far away. If you never, it's just like, I don't know who put it so far away. And you just up so early in the morning. And it's like, I'll go for a walk. All right, let's see if it paints correctly with my one monitor here. So can everybody see the screen?
Yes, what a nice graphics. Yeah.
When Googling for it. So yeah, so Cloud Native New York, welcome everybody. I'm Robbie Lockman. So today we're talking about something called AAC. You're gonna give another tech acronym here called Application as Code, a standard definition for GitOps. If you're unfamiliar with what any part of that means, don't worry, we'll go on a little journey and a little demo. Now, by the end of this call or end of this webinar, it might make slightly more sense. So before, for the official recording now, so I'm Robbie Lockman. I'm the field CTO at a little startup here called Shipa. Prior to working at Shipa, I was a director or chief architect actually at Harness. And then prior to that, I was working in the PaaS space at Mesosphere and Red Hat. Only the one missing was Pivotal. I have friends now, I suppose, so captured them all. Two things that I live by. Kind of the older I've gotten, I start to realize that if I built something that worked right the first time, it actually didn't work. So I never got anything right the first time. That's a lot of experience to come up with that. And also iteration is super key in software. Like trial and error is how software is made. You know, if you ever watched how I write software, it's 100 fails and at 0.5% of the time it might work sometime. And that's it. You know, that we have to support iteration is key, and safety is key in building software. So enough about myself. What are we going to be talking about today? So, well, surprise though, we're going to write a little bit of software, more from I think a more of a little bit of theoretical angle here, and then GitOps. GitOps. If you've heard of this term before, you know, there's a little bit of a hype train around it, but I'll kind of unpack where it came from and some of the principles around GitOps. It's like saying microservices or serverless, what we were talking about before the record button got hit, and then also, how do you application as code, aka what is this thing called AAC, and just a few of the players in the market about it. So let's write some software. Let's do it. So I'll break down a couple of time frames here. So there's this time called BK, not Burger King, but before Kubernetes. And actually, the person who writes for VP of engineering, I always stick him in the presentations here. But if you take the way back when machine, which is kind of ironic from being a cloud native meetup, what we were prone to, 10 years ago. As a developer, our environments were pretty static and pre-provisioned. So I had a VM for Jenkins. I had eventually multiple VMs for the application server and a VM for other development-centric tools like an Artifactory instance or an Access instance. But prior to Kubernetes, if, as we alluded to, there's a second person here, it's not self-service, that I had to go talk to my buddy Vivek here that, hey, you know what, I need multiple JBoss instances to deploy to, or hey, you know what, can you set up HTTPD? Can you set up ModJK? Can you set these things up? But kind of what's happening here is that there's separate syntaxes and there's separate sets of people with separate sets of expertise, which has a long lead time, right? And so this is what we used to deal with. And this is what software development looked like back in the day. So actually, when I started, this is what my stack looked like. I wrote some Java, I went into a war, there was some JMS for the event-driven stuff, but one of three target platforms, right? So deploying to WebSphere, WebLogic, most of the time I was deploying to JBoss, but there was a tight coupling between, hey, or I wasn't the one deploying, right? So I might have built it locally, but there was these mythical creatures, a middleware engineer, a release engineer, and people are missing on the milk carton these days. You're replaced by a platform and DevOps engineer, which I'll talk to you how that kind of evolution or revolution occurred. But that was it. It was simple. I can focus on Java as a software engineer, and going to a Java-based system. If you look at a stack, actually is fairly representative of our stack here at Shipa. Like if you take a look at what the stack looks like today, I'm the same Ravi, I'm just older, grayer, and bigger in the wrong way in size. But there's just a lot going on now from an engineering perspective that you have to take into consideration. Not only did the language become more granular, from a Kafka perspective or Node.js perspective or Angular perspective, is that there's an entire journey. If you go anywhere from left to right in this eye chart here, each one of these journeys are bespoke, right? Okay, we're building in Java. We also have to automate, kind of some of the infrastructure with Terraform, and then, we have to build it with the CI, a platform like Jenkins, and then, okay, it gets even more complicated as we start putting Kubernetes-ish things in the mix here. So like, okay, we have a Docker image that's running JBoss, but then it gets more complicated. Okay, yes, we're running Kubernetes, and so not only that we have to package the application to Helm, but we have multiple environments. So I use overlays, we customize, and we have to pick an observability stack. So Fluentd, StatsD, a little bit of Prometheus, and we're actually in 2 cloud providers. So we're in AWS and GCP for resiliency. But each one of these is a bespoke journey. Remember, I'm a Java software engineer. And adding all of these things together, in my eyes, are non-functional requirements, or NFRs. Like, I don't care about a lot of it, right? But have to care these days. And it starts adding complexity to the equation. And it gets into another problem, right? So look at this eye chart. Who owns all of that, right? So if you're thinking about in your particular organization, your particular team, is this little thing called Conway's Law. Conway's Law, if you're unfamiliar with what it is, it's that system design follows communication patterns in your organization. So your experience going left to right will be different if it was designed by a system engineer. It would be different if it was designed by a DevOps engineer. Your experience would be different. If it was, especially if it was designed by me, it would be no path. It'd be very quick, but lacking lots of the confidence building exercises that we would need. Or like, hey, this person who's missing in action, was it designed by a release engineer? Has a lot of expertise in the science of releasing something. And it really has an impact on your day-to-day job, and also just the toil and just the unknown, which when you have to get something into production. So what we end up with today in very modern teams is that there's this concept of being a full lifecycle developer, right? And so who best to, there's a couple of companies that made this popular. I'm actually pretty pessimistic about this delivery model. Is that there's that book company in South Lake Union in Seattle, and there's that movie company in Los Gatos, or a DVD company, depending, not naming names here, but they really embrace this model of being a full lifecycle developer. So what does that mean? It means that if you write it, you run it, or if you operate what you build, or you run what you write. I got the word right that time. Okay, but who best to know the service than the person who wrote the service, right? So there's a lot of things being inferred there. Versus now that system engineer or release engineer is now a platform engineer, and so they're focused on the platforming or the tooling. If we take a click and say, okay, they're focused on our Kubernetes platform, they're making sure that there's capacity in the cluster, that the cluster is robust enough to handle failure, and also they're only responsible for onboarding and offboarding workloads, right? And so they might not get into the nitty-gritty with you that, oh, this is how you should develop something, this is how you should package something, this is how there are constraints that they'll put upon you, but their main concern is on off, and they get very, very good at that. And so alluding to, now we're in the K era here, the mighty Kubernetes, and it really opened up a lot for folks. So pretending for the folks on the live webinar here that imagine we were all had different roles, right? So we have people who are in operations, we have people who are in, let's say, the development side or feature development side, we have people who are in between. With Kubernetes, we're able to speak the same language. Like we all could read this and kind of understand what's going on here, right? That we can read this YAML and say, oh, this is a deployment spec. Yeah, you know what, Robbie wanted one replica, or someone who's deploying this wanted this, minus there's some, some hooks in here for templating values. But that's it. It's human readable, this format. Now, where it gets into a little bit of a challenge is that I call it an inception problem. I actually read a very funny tweet. I wish I put it in here. It was that someone was saying, hey, I actually never wrote a Kubernetes YAML before. I just copy and pasted from like the Genesis or the Inception YAML. We just kept adding to it over like 2 or 3 years, and then we have what we have. It was very true. Like any configuration-based system, like it's an exception problem that how do you produce, like how would you author this? Like if it was in a general programming language like Java, or like I can write this, but understanding the limitations of the system get difficult. And so, but kind of not talking about that quite yet. Let's talk about GitOps. Okay, so Kubernetes comes around. Now there's this other concept called GitOps. So it has get in the name as a little bit of foreshadowing. And so let's talk right before GitOps became popular. So over the last like 5 or 6 years, these particular, or probably more now, like these classes of tool called infrastructure as code, or IAC. So you might hear something called Terraform or Ansible or Chef or Puppet became pretty popular. So if we go back to that very bespoke journey going left to right, not only are we having to offer those things, but now having an IAC, it gives us a couple of key benefits. One, it's repeatable, right? Don't worry about having to log in and bespokely doing stuff. No, it might be preaching to the choir here, but this is what kind of IACs also unlock. And since they're repeatable, they're also consistent, right? Like leveraging an infrastructure as code, they kind of lay down the necessary infrastructure for the application. If you were to run the same Terraform script twice, it should produce the same output, right? So it should be idempotent in that fashion. Also, they're callable, right? So like as CI/CD pipelines became more popular, kind of a shift in the popularity of IACs actually took off, because if you go back to the way back when machine, right? Like, your build process was segregated from the deployment process because there was infrastructure that had to be laid down. Now, it's very common today that infrastructure is, what's the word I'm looking for here? Provision, there we go. Infrastructure is provisioned at the time you're deploying something. Like, we're used to the public cloud. We're used to that. We're used to infrastructure being spun up as we're deploying something. So IACs really help with that. And even in my example today, I'm actually using Crossplane. So if you're unfamiliar with it, I'll give you a 30-second crash course of what Crossplane, the Kubernetes-based IAC is. But let's talk about actually what GitOps is, right? And so I'll kind of start with like the obvious, Git. And this is where I was trying to sneak my dog into the presentation. So as a software engineer, the genesis, or like kind of like we're telling the world that we're ready to do something when we commit. GitOps can like, it's like any other paradigm. Like there's a very actually stringent definition of GitOps, like a microservice. If you read Bob Fowler's definitive piece, a microservice has to use JMS, or it has to have separate copies of the data, right? Like it's not just representing a movement, like we're decomposing the application. There's actually a very strict textbook definition of it. Also similar to GitOps, but not to get hammered in that. Hey, you can take some of the principles away, but hey, as a software engineer, you're telling the world you're committing something. Let it be in clear case, subversion, pick your SCM of choice. When you commit, that means that you're A, ready to integrate something, or B, you're ready to something, and your idea is moving along. It's getting more formulated. Here, I'm posting pictures of my husky. When I hit commit, the changes should go to prod. And there's a lot in that comment there, because if you take a look at GitOps, let's talk about GitOps. Okay, so GitOps is this paradigm. It came out in 2017 from a company. They had a definitive piece, WeaveWorks. So the old networking provider kind of reinvented themselves here into a GitOps provider, and it came up with these kind of 4 pillars, like saying, hey, there's a rise in Kubernetes, and also there's ways that we can actually take the declarative nature of Kubernetes and kind of supercharge that, right? So kind of the first thing is, in GitOps, everything has to be declarative. From the infrastructure all the way to the application, all the way to the deployment has to be declarative. So if you're unfamiliar with declarative is, there's imperative and declarative. I always like to use the pizza example. Declarative, I would like a pepperoni pizza. A pepperoni pizza appears. The imperative would be like, get dough, get flour, find pig, make pepperoni. Like you have to be very exact with imperative, right? But declarative, the system will figure out the answer. Also, if your changes are approved, they get applied automatically. So, kube, CTL, f apply. Sure, if those changes look good, they're going into the system, right? That's as simple as that. Kind of like the more, the kind of intrinsic stuff would be, hey, you know what, the state of your application or the state of what you need is actually in source control, right? So, hey, in version 1.2 underscore release of or some other particular version of what we're authoring or what we're wanting to deploy, the source of truth is in source control. So if it's like my manager would say, if it didn't happen in Slack, it didn't happen. Well, if it's not in source control, it's not going to happen, right? With the GitOps pillar, and also because like you're able to store like a canonical state in source control. You also can measure for drift, right? So like a prime example would be in that replica set example, I declared like one, or I think I declared one replica set. But if I went directly to the Kubernetes cluster and I said, bump that replica set up to 2, hey, GitOps Engine would say, oh, there's a difference between what was declared and what is actually occurring in the system. And this is the reconciliation or auto-healing stuff. So there's a lot of great benefits of adopting a GitOps paradigm. Now, there's lots of tooling out there. It's a fast-moving space. I think any one of these pillars can be beneficial. But with that, there is another problem that kind of occurs, right? And so this might be, again, preaching to the choir, is that there's a sense of like YAML overload, or like there's this overload of configuration. And so if I was going back to, if I was a software engineer, and this is like kind of like where we started formulating application as code. Now, irony, all applications are code, right? But kind of describing a declarative state for an application is that, hey, you know what? I wrote a feature, I want to get it out, but now I have to describe everything, like everything. Oh, not only do I have to describe how a deployment would look, but I also have to describe the networking stuff, like, or I have to describe non-functional requirements. And you start having like all these particular YAMLs. As another aside, my biggest production outage of all time, and this is like not a lot of production now, was I'm not good at networking. I suck. Like, I'm the worst person to talk about networking. I have a Google Mesh at home. I don't know why people think software engineers have like the most kick-ass networking stuff. I use Google Mesh at home. So like, I misconfigured Kubernetes networking policy. I blocked half the internet from our app for 4 hours. That took us 4 hours to recover. Like, as a feature developer, I wasn't really aware of that, but it's showing that expertise has to be shifted down all the time. This whole shift left notion, a networking engineer would have caught my mistake. He or she would be like, "You're stupid." But since we were in Kubernetes, like, oh, the networking people don't touch that system, and this is where this problem actually comes to occur. And this is why I was so passionate about AAC when I heard about it, and now I have a job at Shipa talking about it. Is that it alludes itself to this thing called a feeding problem, right? So a little bit of a food reference here is that, well, you have all these YAMLs, you have this very powerful GitOps engine, but what do you give it, right? Like, what are you applying? What's in your repository? What is not related to the application that has to be stuck, in the repository? So there's kind of like what I've been seeing a lot in industry is that there's this consistent shift to the left, right? So I know I kind of made reference to it a few moments ago that, okay, as a software engineer, we were actually talking about this before we hit record, was like, oh, like what were some of these battles you had, with members of your team, or like tabs or spaces? Sure. Like I know as a software engineer, I wrote a compliant feature. I got a C-, good enough in SonarQube. I'm making something up here, but I know that I met my team's stylistic guidelines, right? Or the organization's stylistic guidelines. But surprise, as a Java or Node.js or Go or Rust engineer, well, I should take Rust out of it. They might be more kernel engineer. Like, I'm not a kernel engineer. I do not know the Linux kernel. I run Mac. It has iMessage. It has Slack. These are tools that I use. Leveraging something like, oh yeah, you need to configure your eBPF filters before you like submit something. I'm like, huh? Like, what are you talking about? And also going back from a networking standpoint, like, hey, I know that as a software engineer or feature engineer, I know that traffic comes in and traffic comes out, but other than that, like, service to service communication or like getting into the nitty gritty might be, my personal preference. Like that's not my job, right? Like someone else should be taking care of that, making sure that there's capacity and communication set up properly and whatnot. But I know it might communicate to certain places, but the implementation of that, I'm not writing a number of Istio CRDs to support that, right? And also, kind of a bold statement here is that Kubernetes can be an indentation detail, right? Again, I kind of even talking to kind of DevOps teams in my current capacity, they're like, our end customers, we could be deploying to an LPAR, to a mainframe for all our customers care. That's true. Like your external customers do not care where it came from. Now, people who do care are your internal customers if you're a DevOps engineer, because they're subject to your entire deployment process, right? And to kind of like fulfill, the kind of the gap, like, okay, like I need to have kind of a more robust way of delivering software. Mr. and Mrs. DevOps or platform engineer will have lots of tools, right? So they might be using a GitOps engine like Flux or Argo. They might be being supported on a service, whether it be Istio or Trafic or Linkerd. You have to package your applications in a certain way. You might have rule sets or policies you have to abide by with OPA. There might be security scanning going on. You might have multi-cluster. I should have put a VMware logo here for pay homage to our host, but also monitoring. You can just go off the deep end on like observability and monitoring. But there's a lot of tools that they're communicating with, and there's a lot of configuration that you have to provide as a software engineer. And this is where the idea for AAC application codes came from. Because here's where the problem set is, right? So I call it the fog of development. It's a reference to the fog of war. So fog of war is it's a lack of situational awareness. It's a term coming from the military, from peace and war, right? So it goes way back. But like no singular person knows how something is going to impact the end state. With that, think about the first time you were on it. Let's say you just changed teams today. I don't know. I'm going to pick on Chorus. Say I joined Chorus team today. Congratulations, or I'm sorry how much you like me, but I'm on your team today. Day one, day one is today. Chorus might give me some task and say, okay, like you need to get this out. Like this is your first like week. We need an X number of PRs out of you, to make sure we don't get rid of you. But there's a lot of figuring out that you have to do, right? And I call it the hamburger regulation problem. Now, I remember it took me a while to actually find this picture. I remember I probably took it out of history books. This is from the 80s, but it was like, well, for a hamburger, simple, delicious hamburger, there are actually 41,000 regulations per this diagram that the hamburger goes through from before it gets to you, right? So it can be from transportation to cooking, the raw materials, like it just gets very granular. But that's similar to what maybe a software engineer goes through if they have no idea how to deploy to production, or like, oh, you need this described a certain way, or oh, hey, especially when it comes to confidence building exercises, like it's really hard to know like what the next step is, because instead of a hamburger and us figuring out how to get the hamburger, this is actually what it kind of looks like. Like, a long drawn out deployment process, right? But probably with some manual gates. And that particular problem can be difficult, right? Saying, hey, you know what? I have to follow the branching strategy. I had to put up with all these code style checks. I had to go get a peer review. Like where does it end? Because it's usually not focused on the feature. It might be focused on the infrastructure or the functional requirements. Like, oh yeah, like feature is fine. This you misspell something in your Istio CRD. Shame on you. So that's where a lot of the challenges actually come up, or at least what my challenges specifically have been. And so this is it, right? You have this fancy GitOps engine. You made, you read the book. You got, the O'Reilly book about GitOps. You're ready to go. But what do you give it, right? Like, what do you feed Argo? What do you feed Flux? What do you feed Tecton? Forgetting which one Tanzu has included, but what do you feed it, right? Like, you feed it some Rego. You feed it an overlay. You feed it Helm values, and it gets into a feeding problem. Like, what exactly do you feed the engine? One of my friends, she said, oh, well, the octopus has a helmet on, so it's not going to be able to eat. I'm like, oh, okay, yeah, clearly, but it's just a large amount of configuration or that you're feeding it, which is a problem. And this leads us to AAC. Finally, we're here at application as code. And so there are a few players in the AAC marketplace. And so there is a CNCF project called KubeVilla that is out there. And there's a Microsoft implementation called OAM, Open Application Model. And there's Shipa also. So we have like differencing of opinions, but this is like the end of the class of software, class of tools that this falls into. So application is code. So going back to you all, I'm a chorus team. So I survived the first day, second day, now the job. Time is moving fast here. And so I might be given, say, okay, you're not too bright about building something from scratch. Why don't you change something? I'm like, okay. And so I from a software engineer perspective, if let's say, okay, we have something that's running on Kubernetes, you need to make a change, I might open up source control and say, well, what built this particular change? But, God forbid that change is a Kubernetes manifest that has to be changed. This is kind of like my recourse, right? Like, can I describe the pod that it's running on? Tell me a little bit about the application out here. I'm running MariaDB in the back. It's like there's a pod or stuff that's running here, but this is what I would have to do, right? And as a Go or Java focused engineer, this is gibberish to me. It's like, what's annotation and label? Like, what are they the same thing? Like those are things that are going on in my head, right? And it just looks confusing, right? Describe your application. So one of the goals of applications code is having a very, very standard and simple way that's software engineering focused to describe what's going on in the application. And so there's just these like 9 pillars in AAC, like, hey, what exactly is an application? And some of this is a little slanted towards like Shipa or open source project, like Catch's implementation of it, but they're kind of like the other toolings take this into consideration. Also, is that it goes back to this intrinsic question of like, what is an application? It's like if a tree fell in the woods, no one was there to hear it. Is it an app? Or there's one with a bear, but it's not safe for work to talk about what the bear does in the woods. But it's like, what is an application, right? Well, you can define an application as these 9 pillars. Like, okay, like that your application has an endpoint, or your application has inbound or outbound traffic, or your application it needs to be subject to a few non-functional requirements, like a security stat, or your application has resource limits attached to it, so it can only scale a certain way, or your application is coming from certain places, right, or has certain people who are able to log in authorization-wise to it. Similar, we kind of bump that a little bit higher, so like kind of up and beyond the AAC stuff. It's like, okay, like part of what the Shipa platform will do is that will also create like a little micro path, like, oh, like by convention, it'll create an address for it, or like, hey, you know what? This is where the particular application is being built from, or build using a build pack. Let's build the application for you. This all has to do with a concept of a framework, and I'll actually show you a framework in action, and also a set of people that's behind it. I will unpack this. So I call one of the party tricks I like to do is I'm going to switch gears now to developer experience, or DX, right? And so this is something I call the one-line developer experience.
Ravi, can I ask a question if you don't mind?
Yeah, sure. Feel free.
Yeah, I mean, so when you talk about like an application, would you consider like a microservices an application, or you would consider application in the good old days where it's like comprising of every functionality within that application? How would you, and also like within the slide, would you also consider like databases, NoSQL, load balance, all those into the mix? I know it's a long-winded question, but I want to get your opinion on this.
Yeah. There's like my personal opinion, and then there's like, how like Catch and Shipa would implement that. I wouldn't talk about how Catch and Shipa implements it. Like, what takes up an application? It's like every organization is different, right? Like, is it an item in the config management database? Do you subscribe to ITIL? Is it an endpoint? Like, I think if you were to ask like someone off the street, like, hey, what's an app? They're like, oh, it's an endpoint, or it's something And going back to like, hey, is it a microservice or if it's like a monolith? It's eyes in the eye of the beholder, right? What is your deployable unit for that application, right? Is it a very singular service that has a singular container? Is it this large war or ear object you have to deploy? I know it's like a non-answer to your question. Beauty's in the eye of the beholder. I would view an application as everything the app needs to survive, right? So not only is it, let's say we were, I don't know, I'll pick on the place I have to wait in line, Shake Shack. I wait in line there ungodly amounts of time now there's Shake Shack here where I live, but like when I was living in New York, go and stand in line for like a half hour to get a burger. It could be, hey, their pricing application is an application, but also has a backing database, right? Like, they have to persist it in a couple places or they have credit card data. And so I would say where the boundary of an app would be everything it needs to survive by itself. So the infrastructure, the networking, the storage, the database. Now, on the Shipa standpoint, we view an application as an image. So like personal opinion of what it is versus company opinion of what it is. Shipa view the world as it's this image, whatever the image can provide. That's it. Did I answer your question, or at least a little more food for thought?
No, I think you did good justice to the question.
Cool. Any other questions? Love to keep it interactive. Let's see. I'm just fighting with Zoom. My singular, it always covers like the most critical piece of the like browser bar with the Zoom controls. All right, so I'll do a little bit of a party trick here. So from a DX like developer experience, it's kind of like a problem set that we're like hyper focused on at Shipa and also our open source project Catch that we're working on. Going back to the feeding problem, I used to lie to people and said like this is called a one-line developer experience, but then I was told there was actually 2 lines. Then I was like, oh, I've been lying this entire time to everybody. But 100% increase the number of lines to 2 is that pretend like, hey, as a software engineer, you might know how to build an image, right? So you can build by convention. If it's a Docker image, you can execute Docker build, or you can finagle a Docker compose or a Docker file to kind of build some sort of image into what you need. Now, where it gets a little more difficult is that, okay, this image needs to run somewhere, we describe it in certain ways, have a rollout, we need to have connectivity, we need to have storage that goes along with it. It gets a little funky after that. So this is Crossplane. And so the kind of integration that I'm showing here, so Crossplane is the infrastructure as code provider. They're the Kubernetes centric way of managing non-Kubernetes based resources. So like you can spin up AWS resources, you spin up anything that has a Crossplane provider. At Shipa, we have a Crossplane provider. So this is how a lot of our GitOps integrations work. Basically, as a developer, all I have to specify is like, oh, I'm going to deploy a certain image or tag. And this is the application as code abstraction, AAC abstraction that we're going to deploy it against. And that's it. That's the only thing that the developer has to do. So when you're exposing 2 data points and Mr. and Mrs. Developer are able to get on their way. Now, let me kind of like unpack how this was created. So like, this is the end game. Like, this is what you expose and that's it. So let me fire into Shipa. And so one of the, let me pull up the dashboard here. So this is Shipa in all of its glory, right? So typical enterprise tool has navigation on the left, some sort of metrics in the middle. We've all seen tools that look like this before, but kind of like what is powering my ability, or the ability to define 2 things, is a concept called a framework, right? And so you're basically deploying your application to an AAC framework, saying that these are 9 pillars of what makes up an application, and then we can deploy against that. And so let's take a look at what these pillars are here. So also anything that I do here, it can be done via command line. I actually set this entire thing up using Terraform. Move this one more time. So everything that I set up here, this, if you want to see what AAC looks like, here it is. This is the HCL version of AAC. 2 acronyms in the same sentence, framerized. But I'm just a little bit stronger with Terraform than I am with some of the other IACs. So, but going through the UI, I say, okay, like if we to provide, this 2-line experience, this application as code, the first thing would be, okay, we need to kind of name what we're going to be. This would be for a platform engineer or a DevOps engineer would be setting this up. So kind of the first thing would be, okay, give it a name. The second pillar, that what's trying to get resolved here is like, well, for, let's say I'm a tier 2 application. I'm just going to make the arbitrary tier of application I'm here. You might say, for a particular tier of application, how do we start imposing resource limits on this is Kubernetes centric? Like, how do I start imposing what a resource limit is? Does the developer have to self-impose it, or does the system can that impose it? And so you might say, we're offering like 8 gigs of memory, 100 CPU shares, and disable swap, right, for a particular application that's being deployed. Kind of where it gets a little bit more interesting though is the rest of these. It's okay, resource limits, they can tack that on the container spec or the spec or whatever. Access control would be, oh, well, who has access to this abstraction, right? So is it a production team? Is it the development team that made it? Who has access to it? Also, for again, this is all geared to like non-sophisticated users, right? Saying, okay, I have a very simple application, or like I'm an everyday simple application. Like, how would I go about figuring out scale, right? So as a platform engineer, I might be saying, hey, for any given, for this tier 2 type of application, go ahead and allow, Robbie's tier of application to scale, just have another replica. And this is a benefit of using Kubernetes, right? You might say, hey, you know what? Just go ahead and allow that application to scale one time or a number of times. This is not going to replace something like a cluster level autoscaler like AWS Carpenter, but for someone who doesn't want to author HPA rules, this would be something simple. Registry controls, your apps have to come from somewhere. Let's say that this is just limiting things to certain private registries. You could say, hey, our team is on AWS, we use ECR. We can only pull images from our own Amazon registry. Application control, these are taints and tolerations. So like node selectors, like, oh, we have to pin something to a Windows workload. Now, my personal favorite thing about applications code or AAC, or this is more specific to like the Shipa implementation of it, is that going back to about 20 minutes ago, my biggest outage ever was a networking related outage. Like I misconfigured a CIDR in a Kubernetes networking policy. Shipa in plain English will actually allow you to say, hey, you know what? Let's by convention talk about your ingress and egress, right? So let me just move all the lovely faces here. Yeah, come on. Single monitor fun.
And sorry, if I can ask, who is filling this form?
Yeah. So, this could be an engineer. Usually, who would be filling out this form would be like a DevOps engineer or someone like a platform engineer responsible for providing some level of self-service to a feature delivery team. So it's simple enough that I can fill it out. Who's not an expert in these things, but also. Yeah, usually be a platform engineer with that. The next piece here would be, okay, so we want to talk about ingress and egress. So it can get kind of confusing. Let's say I was VMware.com, right? So I was the public facing website for VMware.com. So clearly I would be like, we need all traffic to be allowed onto our website, but because we're the public facing website for the company. And what's also very interesting here is that we also the trickier part is the outbound communication, so the egress communication. Let's say that this is where I screwed up in my production, the prod 0 outage that I had a couple years ago. Is that okay? Well, you know what? Let's say we have like build.vmware.com or like customer.vmware.com or like vmware.com/like authentication or login. We can say like, hey, you know what? For any one of these applications, we're only going to be allowed to talk to, pretend this is like authorization service, right? Like sort of my OK app. So that's it. There's no other configuration or networking policies that a developer has to do. It will lock it down in that sense for you. And that's pretty cool. Like I would have saved me heartburn a few years ago. Kind of like lastly, going back to like some of the AAC stuff would be, oh, like, is there a security scan that you need to attach to it? And also, this is Shipa specific here, is that we have the ability of visualizing the Kubernetes objects in a developer fashion. So I'll actually show that really quickly. So, and that would be kind of like the end of like my Shippy-ish talk here. But I have a few things that I deployed. They're deployed in a couple of clusters. But if I were to take a look at something that was deployed, going back to, it's like my third day now in Chorus team. So I survived day 1, day 2, it's day 3. I had to cheat a little bit on getting my job done, but this is actually where Shipa got to start. Like, the founder had an idea that he was very confused with describe pod, and he didn't know what they were. Kind of party trick again. Like, Shipa can display all the necessary objects that like were developer centric, saying, oh, here's a config map that the application used, or hey, this is the deployment spec that it used, or hey, these are the service account that it used to deploy, and kind of visualize what the running application is using. It's also kind of, you have the ability to enforce policy-based decisions on these. So if you were to say, hey, I only need to execute a certain number of policies, we can enforce that for you also. So, but I don't want to make it too Shippy here for the meetup. Let me see if I had. Oh yes, I will pitch our open source project now. So if you like what you see, what you saw, I know I gave a very cursory view of the world. We have an open source project called Catch. Catch is our policy engine and an abstraction engine that Shipa has we made the product off of this. But if you're curious about how to implement this, now you can use a free version. We have a free on-prem and free SaaS version of Shipa, but if you're looking to kind of extend this into your own platforms, you can definitely take a look at Catch. Also, we're part of the Continuous Delivery Foundation with Catch, and so we have our Getting Started guide that we published late last year with the Continuous Delivery Foundation. So that's kind of like the kind of focus area right now for Catch's deployment-centric stuff. So, well, with that, that's all the presentation that I had. If anyone get in contact with me, you can hit me up at Robbie Locke on Twitter. We have our community Shipa Slack, and also my email address. And I can give you a much deeper dive on Shipa. We don't want to bogart our host meeting Shipa related stuff today.
Thank you.
Yeah.
It's really interesting, and congratulations for the project accepted on the CNCF Foundation. That's also a big hit.
We're in the sandbox process right now. It was just that the Continuous Delivery Foundation, like we're a member firm for it. So, but keeping our fingers crossed. If you have friends there, you can tell them to vote yes. Vote yes on Catch.
Yeah.
What is it? Yeah.
Awesome.
So it's interesting then. It's really what you are looking to achieve with this is I want to empower the developer by just giving easy template that he can a form, really ask yes or no, or provide a little bit of a detail, and from there we are going to do the configuration that's needed for your application.
Yeah, that's on. Yeah, it's just like hide the complexity, plain English, yes or no, or anywhere between the gray area, like a slider type of rule, and that's it. Like, no need to worry about what a PVC is. I thought PVC was a pipe, not a persistent volume claim. Kubernetes. I have lots of examples like that. I thought Docker was a pants before I learned it was a container format. So plenty of examples of like that.
Yes,
Yeah.
it's sorry, Cora, go.
No, I just thinking there's a lot of value in that. I think that I find in my own work, like that's a hurdle, right? Like you build your container and then it's like, okay, where do I go and copy and paste some example from something I did before or something I saw, or it is this tedious task every time. And it does demand that you understand where you're and make decisions about how your application is going to be deployed. And, because there's not just one way to do it. So it really can be sort of this like a blocker in being more effective and productive. And so it's nice to see this approach. I think
I also like all the standard that it's going to produce, because now I'm not only I'm not adding possibly when I do a cut and paste on something, I'm gonna leave an extra character. I'm gonna do something that was not supposed to be done. And eventually I could also say, oh, maybe I can also add this and be a little bit imaginative on, I think this would work better if I can customize. And I saw that on a thread on Git that on the Stack Overflow that if I do it like this, it's going to be better. And so now you start also to have a lot of different configuration that not necessarily you need how to maintain. In this way, you have a cookie cutter where if this is the default, we are going to apply that.
Yeah, absolutely. And it also depends where the expertise is, right? Like going back to like Conway's law, or like us three have like, let's say 3 of us have like different skill sets. Like my network configuration would be very short because I don't like it, versus like my rollout would be very detailed because I'm good at that. And so like you have a difference of skill set that would heavily influence like, and also going back to maintainability, like say someone else had to pick up the work, right? It's like, oh, why did this person do it? Like they're missing stuff, or they're overly verbose, which is even the worst problem. And so yeah, it's able to kind of harmonize, like don't worry about the NFRs so much, and focus just on the feature. That's kind of where we're going.
Yeah.
It's definitely a need, because even from a perspective when you hire someone, how many things does this new developer need to know before it can be useful to the company?
That ramp period is a lot. So like one of my favorite, going back to Stack Overflow, I have my squishy ball now, like one of my favorite things, like I love reading the end of year survey at Stack Overflow, like the developer surveys, like it's my favorite thing to read. I wait for it every Christmas. It is here, thank you. And one of the very, very interesting trends, and like it hits really close to home, is that after working on like several development teams, was like, oh yeah, like this is occurring. Like over the last like couple of years, like you look at like the 21, 20, 19, 18-ish, Stack Overflow end of year surveys, that they kind of like take a pulse, like, hey, what is the average ramp time? Like how long does it take to Gabri's question, or her point there is like, how long does it take before you become productive, right, on a team? But also like, so those times have been ratcheting it up ever so slightly every year, which is odd, right? We have all this automation, all this tooling, but productive time is big. It should be going down, like should be decreasing the ramp time, but ramp times are increasing. Also, it's no mystery, like we're on projects shorter amount of time, like no longer are you at IBM for 25 years on some arbitrary team. It's like 6 months, or you got to like embrace the Spotify model, like 3 to 6 months. And then just change the tribe, change the guild. No change teams, it's fine. So like on both sides, like the amount of productive time is like getting compressed, which we can only guess why. I have my opinion. There's more stuff to learn. I have to learn we have to learn so much more, even infrastructure related things that takes time.
And how many of these things will be outdated in 1 year, 2 years?
Yeah, it moves fast. Yeah, things get updated. Yeah, they do. Yeah. There's this like balance between like, I don't know. I mean, there's 2 ways to look at it, right? There's always like, as things mature, like, I guess I was thinking while you were talking, like an example of like, you don't need to know, like you want to talk on the phone, right? You don't need to know how the phone transmits your voice, right? So it really is like, that really drives that, because I feel like I sit in this world where like I identify with the developer, but I also like to know what's going on in the background. So like the idea of a developer who really doesn't need to know anything about Kubernetes, like it's a very like valid idea, but like it's not me, right? I want to have one foot in each world. But if I think about another example, like a telephone, like I don't care. I just want to talk. That's really like that developer experience, and the infrastructure and the configuration of the infrastructure has to reach a level of maturity where we view it as a telephone, and it's almost like this appliance, and like, and to the point where we won't care, and it won't matter. You don't have to know how the phone works to figure out that you're dialing the wrong number, right? The level of debugging that you have to do does not require you to understand what's inside of the phone. So that should be like the driving, that's the goal, right? We need the infrastructure to get to that level of maturity.
Yeah, and you're exactly right. It's like different strokes for different folks. Like some people, like you're saying, like would care, how something was occurring, versus like at certain points, like that pendulum might swing to other folks. Like when we were going through like prepping catch for this sandbox, right? So we were looking for like, external contributors and whatnot. We talked to one company. You can look at the GitHub stats who they are. They do a lot of taxes, for consumers, right? Like they were talking to us, and they were like saying, oh, like when they built their internal Kubernetes platform, company name KS, career service that they have, they said about 70% of people didn't care. They just did not care.
Yeah.
I was like, that many people at that company. I was like, wow, you're like a great employer, great contributor to open source space. And they're like 7 out of 10 people here do not differ from our archetype. They do not differ from our service that we spin up for them. Now they'll change what's going in, but they will not stray from what we give them. There's some people that are a pain in the ass to them, but that's usually like where they were trying to solve for the 70%. Like we're spending all our time building for that. Yeah, it was wild. I was shocked at that high of a number.
Yeah, and imagine how much time is spent on that, like 30%, that customized 30%.
Yeah, it's just like they have to open the gates.
Yeah, for the one who doesn't want to be standard.
Yeah.
So we have like one fundamental question.
Sure.
So in the new world of supply chain issues happening with the rapid pace of like deploying the application, how does this actually help from a security perspective, right? I know we talked about policies, but from a supply chain issues and also from a threat modeling, right? I know the rapid pace of deployment is essential, but how do you actually, what is your take on like a threat modeling perspective, so that you're not undertaking security risk as you roll out new features every, say, day or every week, for example?
Yeah, I mean, I'll give you like my personal take on that, right? Like, there's two forces at play, and I'll side with one of the sides. And so it's like there's folks who need to make a change, and there's folks with people who don't want to make any sort of change. Fundamentally, anytime you introduce a change, introducing risk, right? Yeah. But also software ages like milk, not like wine. And so like there's an inherent risk of like not making a change, and there's like inherent risk of making a change, right? Like you're stuck between a rock and a hard place. I'm in the camp that make the change. Like what will drive security is, hey, you're able to adapt. If you found, let's take like Log4Shell, something that well publicized, like in the news, like you have to go and redeploy a lot of stuff. You rebuild whatever is using Log4j provider to a different patch version and redeploy everything out. If you're able to make rapid change, you're also able to adjust your security posture. But on a double-edged, that being a double-edged sword, as you're including more things or you're pushing the unknown, the fog of development all the time, it gets difficult, right? Like innovation will be risky. kind of a more of an intrinsic answer. I always like talking about, open source security and stuff like that. Is that the original authors of the projects did not foresee this occurring, because there's several of us on the phone. I would say at least 6 out of 7 of us are good. No, we're not. Okay, we're all not nefarious, but making a joke, one bad actor here. But we try to do what is best to the knowledge that we do have. And so to that being, let's look at log4shell. Who knows? It would read anything you tell it. Who knows? Clearly it would read Jindy configuration if you inject Jindy into something that has to log, right? And so as a user or contributor to log4j, I'm not a contributor, but I would not anticipate that, right? And that's how a lot of stuff kind of changes. But when they figured out that this was a problem, they were able to patch it and redeploy. So fast change also helped remedy the threat. It's kind of the more changes, the bigger your surface area, but also you're able to reel that in. Also, I can tie it to AAC. It makes deploying easier. So you don't have to worry. It's over in the central spot. You're able to just kind of enforce certain decisions. We will only use this service mesh, or we'll only use these type of networking policies, but it's kind of a broader picture question. I hope that, again, another non-answer answer to your questions.
I also really, oh, sorry, go.
No, I said it was a beautifully answered question, right? I think when you talk to management itself, right? What do you want to do? I mean, do you want to take more risk, or I think it's a balancing act, right, in the long run.
Yeah, absolutely.
I really like your analogies. They make really clear the problem.
Yeah,
And
they're
the
fun.
last one, it ages like milk, not like wine. It's so perfect.
I want to make software that ages like wine. I'm gonna figure that out one day.
Gotta go back to
Gracefully
Cobalt.
age. Yeah, Cobalt 2. Cobalt 2.
I'm gonna use this one, Ravi, directly next week. I'm gonna mention you, but
Go
I'm
for
gonna
it.
use it.
Yours to keep. I'll give to you all.
All of the slides actually, I love the hamburger slide.
Oh my God, yes.
That was amazing. Because you don't people talk about policies and all the things that a supply chain has to check for compliance, I feel like when you're very removed from that stuff, that it happens, but you don't really understand why it's so complicated. And that hamburger thing, it's true. The McDonald's burgers have to be very much equal. So you're the pickle has to be this thick. And so there really are all these minute checks on everything that you do. Yeah, that was a great one.
But the guy that's going to sell the hamburger, or the one that's gonna fry and do all of this, they don't care about all the regulation that came before.
Yeah.
They don't need to know how long does it take to onboard a guy to work at McDonald's. I guess it's this is your parananza, Cora. How do you say that in English? The thing that you put on top.
Your station, they work in stations, so this, you're the burger
No, but
station.
you need to put a gown to make to save your clothes.
Oh yeah, like an apron on or something.
The apron. Okay, so this is your apron. This is the tool, and that's the kitchen, I guess.
Yeah.
It's not that much, and they are able to deliver. So can we do this? The same thing for the poor developer that needs to be one-man band.
Yeah.
Okay. Are there other questions? Okay. Well, this was really nice, Ravi. It's been such a pleasure meeting you, and it's I'm very happy of everything that you do with us and shared.
Yeah, thank you so much for having me. Always a big fan of the NY area meetup. Brings me back to my New York days. So, the glory days.
Yeah.
Glad to meet y'all. See y'all in the future at future conferences though.
Yeah, really grateful, Robbie. Yeah, I'll whatever conference I go to, I'll stop by the Shipa booth and I'll see if I get to find you in person.
For sure.
Yes.
Cool.
Thank you very much.
Thank you. That was a great presentation. And
That's
thank
all.
you, yeah, Sunny and Arunish.
Yeah.
Thank you for joining us. Arunish, thank you for the excellent questions. We hope to see you next time also.
Thank you.
Bye-bye.